Okay, this is anyway English class, speaking class. So last 1 month, Professor Han conducted a fire, which is really important, and he happened to speak English. Really, it doesn't matter whether it's English or Korean, but this particular class, a few classes in OSE are the English-speaking class because we have 14 students, and also they broadcast the whole content in internet. So that's so you attended a few of the English class before, speaking class. That's what we're gonna do. But in off hour, we can speak Koreans or Japanese, whatsoever. Okay. Okay. For last 1 month, we talk about the fire. So as you see here, we have a fire. I spent almost the whole my life in the transient response phenomena in nuclear reactor. That's at the beginning of my career. Then I getting into the explosions. Within the explosion topic, I happen to really involve in underwater explosion for about 30 years. So, so explosions, fires, and explosions. And in our department in OSE, I maintained a small research lab, as you may know, for the last 3 years. So under my direction, we have a total about 12 students, as I see. One student, Higyu, is working on doctoral degree. Rest is the master's degree. And 9 graduated already, and 2 are about to graduate around the summer next year. So they all involved in underwater explosions mainly. So, but this time I discussed with Professor Chang. He's working on offshore platforms and FPSO and all that. Then frequently the situation arises on the platform fires, platform explosions. So explosions is not, fire and explosions is not the event happen once a year. It's not. Believe it or not, the explosion really means that could include the gas explosion, which is very popular in offshore platform accident, or underwater explosion is another type. Another type is ARX, which is called air explosion. And so last spring, Professor Chang and I discussed about maybe generate a course which combines explosion and fire together. Because when gas explosion occurs, subsequently, there's always a fire is coming after. and you can't really separate the two together. Then underwater explosion is concerned, no fire. An explosion occurs in the fire, in the underwater. And heat transfer nature is not that really important in underwater explosion. But in a sense, when the detonation occurs in the water, of course, there is the heat transfer problems comes right in there at the time of detonation. But in the shock process, you don't have to consider the temperature change because heat really absorbs in the water, and you don't have to consider that phenomena. So what we have decided that time is, well, let's somehow consider fire. And also explosions. Then in the explosion, I kind of considering underwater explosions only. So there is some disconnection between the fire and underwater explosion. So until last mid-July, I was wondering whether I should cover the explosions in the air. Then when I talk about explosions in the air, which is not really good in a sense, the application to offshore structure may not that good because that area is a gas explosion mainly. Gas explosion, as you may know, you can call that as fuel and oxidizer mixture explosion. Underwater explosion, it never happened that. And underwater explosions is really explosion by chemical element, chemical substance, something like a TNT. So that's more applicable to Navy kind of the problem. So when I travel in the conference in some place in California, then I happen to, when I really do search in internet, I happen to find the gas explosion handbook. I think some of you maybe saw the gas explosion handbook. Anybody? I talked already to a few people about the gas explosion handbook. So here, some portion is gas explosion. I want you to check, just to type in gas explosion handbook in the internet. I want you to do that today, okay? And if you type in the gas explosion handbook, you have to put the handbook in. Then the first two references, you will see that and open it. And that's what I'm going to use it this month to cover the gas explosion. I feel that particular handbook is excellent handbook. In a sense, few equations, okay? Few equations, however, to understand the concept of gas explosion, that handbook is absolutely best. I could capture whole scope of the gas explosion, which I really always insist in the class. Understanding the basic concept is very, very important. And that's the book, which is about 100 pages, maybe less, about 100 pages. And as we will see, we'll go through the table of content, or you can say just the content, what that particular book covers it, what I want to cover, how I could cover that handbook. We'll discuss about that, okay? And the gas explosion handbook. I want you to read from the first page to last page, and don't skimming. Skimming is the worst enemy to study. Skimming means just roughly just to read a little bit, then turn the page, and after you finish, you feel, I know everything. In fact, you don't know anything. That's what's happening. I want you to really read precisely what the topics, subtopics deliver to you, okay? And that I'm gonna cover. I really hope, not hope, I will cover in October 12. We missed already 2 lectures because you had a great Chuseok already, right? So you, first Monday, Wednesday, you had a great time. I enjoyed myself also. Whenever we have, I have a Chuseok, I have no children living here. So in that sense, I really miss it. It's kind of the family gathering, right? All family gathering together. Well, all my children are not here. They are all in California. And in California, they don't observe Chuseok out there. So it's a different, you know, the custom in different countries maybe. But I really enjoyed also. Well, we have a great leisure time, but you are busy on the highway, right? Driving around, but I stayed home and good time. So gas explosion. I'm not the expert in gas explosion, but I read the handbook quite well. And underwater explosion, I really worked for many years. So air explosion is slightly different, the things. And as you learn from now on about the explosion, in the explosion, you will hear a few different words which you wouldn't discover in the fire. You will hear about the shock. Of course you will hear about the shock, right? Shock. And you will hear about the deflagration. I think you hear about the deflagration as a Professor Han gave you a lecture on fire. You heard? Anybody can tell, comment on deflagration? What does it mean? They smile. don't be deflagration. You heard? Anybody hear about that word? Okay. Deflagration is, simply speaking, part of the combustion. What's a combustion? Combustion is a burning. Deflagration, rapid burning. We will learn lots of definitions through the handbook that are used in the gas explosion, which you must know. In the shock area, explosion area, deflagration is always coming in as a process, okay, as a process. Deflagration is one thing, and another word, detonation. Detonation, you heard, right? Don't say no, you heard it in even the TV news. Sometimes they're talking about the detonation. What's a detonation? What's a deflagration? It's all similar each other, right? Similar, look like same, but it's not the same. That's what we're gonna discuss in detail. And another word which is very popular is blast. You heard about the blast? Yes or no? 들어봤어, 안 들어봤어? 들어봤지? What's the difference between the blast and the detonation? Somebody could say, what's so important? To understand the process, it is important, okay? So, and could have a little bit more. And fire has a direct connection to shock, deflagrations, detonations, and blast wave. Blast, when you hear about the blast, remember, you have to think about the blast right away on the air. What does it mean? When you think about the blast wave, then you have to think about the explosion or shock in the air. That's what the blast is somewhat different. And within the content we're going to cover, there is one topic which is a response of the structure. You defined the fires, okay? Then consequently, then you define the loading, simply speaking. Shock is a loading. Shock wave is a loading. And consequence from the shock wave is also the time domain loading. So then you define the loading. Fire and platforms. Consequently, explosion occurs. It generates the shocks. Then you have to really know how to handle the survival of the system, survival of offshore structure, right? So one chapter out of 15 covers on the how to analyze or design the structure, like offshore platform, for example. But when you get there, I'll spend a little bit more time on that topics, because now you define the loading, then you have to know how to handle the consequence. Is it going to produce a disaster? What sort of the disaster? What to be careful in terms of the safety, vice versa. That you have to do that. And deflagrations and detonations, for example, we're gonna cover a little more than just the definition. When you say deflagration, there is the borderline which can define the rapid burning, and for the detonation, using that particular borderline, you can really define the detonation, which is quite rapid than deflagration. That borderline is called what? Acoustic speed. Acoustic speed, if the phenomena you are dealing with underwater environment, then it's underwater acoustic speed. Okay? Deflagration speed, detonations, I'm talking wave speed. Okay? Is it higher than the acoustic speed in the water? If phenomena is in there, so you have to really compare with the acoustic speed in there. So usually you're dealing with, when you say gas explosion, I'm just going back and forth, the gas explosion, air explosion, underwater explosion, all within the content of the explosion. Environment is going to be different. The environment for the acoustic speed-wise is quite different. Acoustic speed in the water is higher or lower than the acoustic speed in the air. Lower in the water, lower or higher? Songtae, I know the name of every one of you. I know Julia, I had you before. Yesu, I don't forget the Yesu's name. Easy to remember. Artistic. Of course, her name is not Yesul, right? Yeah. Younggyun, I of course know. He didn't take any of my course, but he's tall, handsome looking. Younggyun. I know Mr. Jung Ho, right? So Pongshik, I know him so well. He has a beautiful girlfriend. That's very nice. So we'll talk more about, is it the wave speed less than the acoustic speed or not? Is it subsonic? Is it supersonic than nature? Subsonic, less than the acoustic speed. Supersonic, higher than the acoustic speed. So that's a demarcation, vice versa. So this portion, gas explosion handbook, somehow Norwegian people, they are way ahead from any other country in the world to understand the gas explosion. So Norwegian, they work on the gas explosion problem long time ago. As I read through the internet, they claim that they are working on the gas explosion 400 years ago. I don't believe 400 years ago, but that's what they are talking about it. But they are way ahead from any other country, it looks like. So that's why this gas explosion handbook, as you read way early in your career, And most of you are going to work on the ocean environment and all the processing, the ship kind of the structures, vice versa. So it will be very, very beneficial. And the other November, this is October, and this could spill over vice versa until mid-December. I'm going to cover UNDEX. UNDEX means underwater explosion. And some of you could say, I don't need underwater explosion. I also just need a gas explosion. You don't know what kind of the life is ahead of you. I told you maybe a few times before, I never expect to be a teacher standing in the classroom, talk about the explosion, talk about the mechanical design, talk about the vibration, talk about the random vibration. I never expect. My personality is like a sit down and think and enjoy listening music like all of you. As I see you, you always plug in the ear and listening music. But I spend the whole life, not the whole life, over 30 years work as a teacher. So you never know. Don't say, I don't like this particular food, I only like this food. It's not going to work that way. So when you say explosion, learn all aspects of the explosion, because life is all interconnected, the same thing. Explosion is all interconnected. Okay? So this course, that's why I'm claiming this course covers the only two types of explosion: the gas explosion and underwater explosion. I don't cover the air explosion. Initially I was considering to cover the explosive shocks in the air, which is a lot of phenomena are very close to each other with UNDEX. So I decided not to at this time, but only covers two, plus the fire. Fire, I'm not the expert. So Professor Han is the absolute best. So he covers, within the short period, he tried to cover too much. Okay? So, but better than nothing. So I think he told me he couldn't do anything else but preparing the lecture for a whole month, believe it or not. That's what's happening. So now teaching is one thing, studying is another, doing the research is another, okay? So that's what we're gonna do. And for the fire, the way he has to give exam, or he has to do something. He and I discussed it. He feels for the fire, let the students write the report. So I know you're working on the report, maybe not yet, but this month, one time or another, you're gonna work on the report on the fire. So that will give you some collective thought on the fire. Don't limit yourself just one corner of the fire. I want you to look at the the whole subject of fire. And you have also selected the research topics for your thesis works, vice versa. Then if you make a connection, it would be more interesting. So please do that. Then somehow he has to give you the grade, whatever the grade. So I want to leave fire to him so he can evaluate your performance. But if you stand here for one semester, about 1/3 times after the teacher spend about 1/3 or half of the time, then it's very, very clear who is working and who is not working. But KAIST students is concerned, all of you are working hard, I know. Whenever I encounter to discuss with outside people, I always told the fact our students are really working hard day and night. But one of my students to work hard, too much, working too hard. He worked until 5 a.m. in the morning. Then when he drove back to the dorm, what happened? He ditched his car because I think he very briefly, his mind is gone, maybe falling asleep. You know who he is, right? Huh? So anyway, you are really working hard, but go home, sleep around 12 midnight, 1 a.m. in the morning. So that's what I insisting to all my students. Kyungsuk, right? Right? So that's the way to do it. Not 5 a.m. So that's what the fire is going to do, to give you the grade, maybe grade and percentage, whatever. He will give you that portion. I say 1/3. Time-wise is about 1/4, but 30% is fair. And fire, the gas explosion is another 30%, I feel. That will cover total 60%. Fire and gas explosion, you can bundle as a one. And lastly, the underwater explosion gonna be 40% because I'm spending a little bit more time on that. And for the gas explosion, I don't, at the present time, my thought is I don't want you to ask you to write the report. Rather than that, I want you to read the gas explosion handbook and understand each chapter. Because this is going to be it establish your base to build the explosion relevant to ocean environment, offshore platforms, any other environment except in the water. So in that sense, maybe I'll give you 2-hour exam at the end of the October, so I can give you the problem set, and you can really answer the questions. Not only definitions on phenomena and all that. That may be more desirable. I haven't decided. That's what we're gonna do. That will cover 30%. And starting around the first week or second week of November, I'll show you the underwater explosion, which is also very interesting on that, okay? That's what we're gonna do. Here, the gas explosion handbook. If you look at the gas explosion handbook, I'm going to show you, of course, starting from a table of content. Then if you look at the table of content, what you will see there is CMR and Gaxicon. You will, when you're getting into the gas explosion, you will always hear about the CMR. CMR is a Christian Michelson research. Okay, that's a Norwegian research company. It's not the institute, it's a non-profit company which exists long years in Norway, and generate the standard, doing the research, all aspect of industrial type of the requirement, actual, the R&D effort and things like that. And that's what the Christian Michelson research. In Norwegian European people, they always use AS. I don't know what really that means. It's like LTD. It's showing this is a company, I feel. Something like limited, okay, CEO. In Europe, they are using AS. This is established in 1992, and this is in a collaboration among the CMI, Christian Michelson Institute, and the University of Bergen. I pronounce it as always Bergen. This Bergen is, I was in Norway just once some years ago. Norway, the Oslo is east of the Norway, and Bergen is west of the Norway. If this is a peninsula there, Oslo would be down there, and Bergen is in the other side. So they call east and west. So it's west of the Norway. They have Bergen. Bergen, I know that town. I was there. We drove out through the mountain. That city, the Norwegian Naval Academy is there. So that's why I happen to know. And the established institute, you can say, constitute the CMR here. Third is Research Council of the Norway. And Gaxicon, anybody knows what the Gaxicon means? I couldn't find what the Gaxicon means. Then a few days ago I discovered it. Gas Explosion Consultancy. Gas Explosion Consultancy. All the actual work is working through the Gaxicon. Gaxicon is the company which they developed the flax. So flax, you have to FLACS, flax or microflax. Microflax no longer they distribute. That's if whoever has that microflax is perfect for the educational institute, but I don't know who has it, but that's what that's what the current the status is. This flags is I forgot. I think this is a flame acceleration simulation package. That's what the flag is. Flame. I think FL stands for flame. Flame acceleration, AC acceleration. S is a simulator. So that's what the flag is. And before I move to Undex, Professor Han, I'm going to bring him back for an hour to talk about the flex code. He has experience to use a flag. And some of you use a flag. Anybody use a flag? Chong? No?
I just simply train the course for the class using I'm not going to use the class.
Some of you could have. I think some of you in your lab used. Pongshik used?
Yes, I.
Yeah. So you can use it freely? 한국말로 해도 좋아. So flag is the code, and that's what I heard. I haven't used myself, of course not, but that's what the flag code is, and where the Gaxicon. Gaxicon manage it, improve it, produced, and so on. Okay, and this is an independent consulting company, and that's they are really working on the gas dispersion, fire, and explosion safety. If you I really search for internet to get any good write-up on the gas explosion. Usually gas explosion covers a small chapter in the book, chemical process book, thick, that much thick. And the gas explosion, a little bit, you can't really see it. So in that sense, to find a gas explosion handbook is really lucky. Don't expect the gas explosion handbook provides you all the relevant equations and everything. But that will tell you, that will give you a whole picture on the gas explosion. Then you know what to do in your particular area you want to pursue, things like that. In that sense, it's very good. So one thing I really worry is this. You have to read that handbook. I'm reading it, still I'm reading it. I'm reading it, not skimming. I'm reading very detailed. And nowadays, all the informations are in the internet. It's just information explosions. Everything is all there, believe it or not. I tried to find that particular paper, Sometimes I couldn't, so I asked Higyu or Yonghyun, would you find it? They find it. 100% they find it. So when you read that book, handbook, I want you to really think. Of course, you can listen to music. Think and keep reading it, okay? And when I talk each chapter, I'm going to really point out the area which is rather important among the whole section or chapter. Then we can talk. Then we can discuss it together. Okay, that's what we're going to do. Okay. See, as you will see here, you see the CMR and CMR lexicon is right there. Whenever you see the gas explosion, that's what you see, CMR lexicon on the right. 3 authors. And I'm going to briefly to go through with you. So don't skip the forward. It's a couple of pages, so I want you to read and the forward. Then we're going to start tomorrow, the Wednesday, introduction to gas explosion. Okay, what's the explosion? Hyunchul, you always sit front. It's good. Right. What's the explosion? What's the explosion? Explosion, fire. Of course, a fire. Shock, of course. Fire, hot. Fire. Explosion. What's explosion? Can you say a few words on explosion? What is it? Is it kind of something like a merchandise? Oh, this is called explosion. Can you do that? Can you do that? You can't do that. So clearly, explosion is the process. Remember, explosion is the process. That's the human nature, and nature is doing the same thing. Typhoon, same thing. From low pressure to high pressure, the things are moving. From unstable state to a stable state, things are moving. That's a process. Explosion is a process. From unstable process moving the substances from the unstable state to the stable state. And it moves very quickly. Its time is depend on the conditions, but move very quickly. Like underwater explosion area, because I know that area so well, then has lots of information here. And within a millisecond, fraction of a second, 1/1000th of a second, the process is done. So explosion is a process. So we're gonna start introductions, and we're gonna look at the definition. Definition is all this sort of the definitions, and toward the end you have another small section telling about the all the nomenclature. And formation of explosive gas cloud. Gas cloud, explosive gas cloud. What is it? Just the common sense is what I'm asking you. What is the gas cloud? Abdullah, what's a gas cloud? You feel, that's what I wants to hear. What's a gas cloud?
Cloud of gas.
Gas.
Yes.
There's a gas there, right? That's it. It could be exploding. Okay, gas plus cloud, right? So gas with the mixture with oxidizers, for example, which is very explosive. Hydrogen, very explosive. So we're gonna, it shows a brief sense, but it shows lots of information. And, oops, deflagration. So deflagration, it shows right there. And detonation and blast wave. It's all look like the same, but it's a different. That's what you're gonna see about that. Response of the structures, offshore platform, submarines, surface ship. And from 9 through 11, which is really gas explosions in vessel, confined structure, pipe, channels is open, tunnels. Tunnels is, a lot of work has been done in the defense people. What happened when explosion occurs in the tunnel? Gas explosions in the tunnel. And 10 compartment buildings, offshore modules. And we're gonna also conduct experiment through using Hanwha company to do the explosion testing confined in the container. That's what we're gonna do April next year. So maybe you're welcome to participate, or you can just come look at the actual testing. Flag simulations in this area, Professor Han will step in. Accident investigations, list of the terminology and expression in conjunction with the definitions. You can look at this together. Okay, some I don't have to talk, but mostly for next 1 month, it's kind of the boring. I don't know what would be the best way to entertain you. Rather than entertain, I want you to really sit down, read, whole week material, then come and talk and discuss. That may be best to learn, okay? And up to 15, but except the 12, 13, include the 14, 15, it's gonna, the month, about 12 hour would be sufficient to cover and share the experience together. That's what we're gonna do, okay?